For centuries, humanity has looked to the sky for answers, building theories, writing equations, and imagining our place in a grand cosmic puzzle. But all of that, our physics, our cosmology, and our understanding of space and time, has just been shaken to its core, because what the James Webb Space Telescope has just seen wasn't supposed to exist. Galaxies are too old, planets are too large, structures are too perfect, and the signal appears steady, rhythmic, and unnatural, refusing to fit into any known astrophysical model. This isn't just another discovery. This is a collision between what we believed and what actually is. The James Webb Space Telescope may have just delivered the most profound warning and invitation in human history. And if it's real, then everything we thought we knew about the universe is wrong. In a series of deep-field observations, the James Webb Space Telescope captured some of the most detailed images of the universe ever seen. But beauty wasn't the only thing hidden in those pictures. In the galaxy cluster Able 2744, researchers found perfectly aligned light points and symmetrical structures, forming patterns that don't belong in the chaotic world of galactic evolution. In NGC 1365, a spiral galaxy, unusual motion patterns suggested gravitational behavior that contradicted our most basic models. But it didn't stop there. Similar anomalies began appearing across multiple images. The farther James Webb looked, the stranger the universe became. Patterns were repeating across billions of light years. Structures showed geometric precision in a cosmos that was supposed to be random. Scientists try to call it coincidence, but there were too many, too frequent, and too perfect. And slowly, the whispers began. Maybe we're not seeing randomness at all, but a form of order we simply don't yet understand. Among the many targets of the James Webb Space Telescope was an exoplanet named HIP 65426b, located hundreds of light years away. And what it revealed left astronomers speechless. This planet is 7 times the mass of Jupiter, orbits its star at 3 times the distance of Neptune, and exists around a star barely 15 million years old. By all known theories of planetary formation, this planet shouldn't exist. There's no visible protoplanetary disk, no leftover material, and no obvious gravitational explanation for how such a massive world could form so far out, so quickly, and remain stable. Some researchers have begun to speculate. What if this planet isn't a product of its current system at all? What if it's a remnant of a previous cycle, a relic from a star system that came before, somehow transplanted, reused, or deliberately placed? For now, there are no answers. Just a planet glowing at over 1,000 degrees, suspended in a system that shouldn't have had time to build it. In one of the most surreal discoveries yet, James Webb imaged what's known as an Einstein ring, a gravitational lens caused by a massive foreground galaxy bending the light of one directly behind it. But this ring, located around galaxy J418, isn't just any lens. It's nearly perfect, a full, uninterrupted circle of light with such mathematical symmetry that even the most experienced astrophysicists were left stunned. For such an image to exist, the alignment between the two galaxies must be extraordinarily precise, down to fractions of a degree across billions of light years. That's not just rare. That's statistically improbable on a cosmic scale. And while gravitational lensing is a known phenomenon, the degree of perfection here is raising far more questions than answers. Could this be a hint of some deeper symmetry embedded in spacetime itself? A sign that the universe isn't as chaotic as we've assumed, but instead governed by a geometry we've barely begun to perceive? But no discovery has rocked the scientific world like this. The James Webb Space Telescope has found massive, mature galaxies forming just 180 million years after the supposed Big Bang. That may sound far away, but in cosmic terms, that's incredibly early. According to our current models, galaxies shouldn't have had enough time to grow to these sizes, organize themselves into spiral structures, or produce the brightness Webb has recorded. These galaxies are described as being as large as the Milky Way, fully formed and stable, at a time when the universe should have still been a chaotic sea of gas. This has left cosmologists scrambling, because if these galaxies truly are as old as the data suggests, then our entire theory of how the universe began is under enormous pressure. The Big Bang, long treated as the foundation of modern cosmology, may no longer explain everything we observe. And as some researchers are now saying openly, We may be looking at a universe that had a history long before what we call our beginning. In a region far from any major galaxy, Webb detected something completely unexpected, a gravitational lensing effect in a patch of space where nothing visible exists. No stars, no galaxies, and no black holes. Yet light from more distant galaxies bends, curves, and distorts as if something massive is hiding there. Astronomers have tentatively attributed this to dark matter, a form of mass we can't see, but which exerts gravitational force. But the precision and intensity of this lensing effect challenge even that interpretation because the distortion appears unusually strong and localized. It behaves not like a diffuse cloud of dark matter, but almost like an object, a structure with defined mass, symmetry, and edges. Could it be a cluster of dark matter condensed into a shape we don't yet understand? Or is this gravitational echo the remnant of something older, something left behind? Some physicists are now quietly floating ideas far more radical, that this isn't dark matter at all, but evidence of something built, something ancient and invisible, still warping space in its silence. Among the telescope's most controversial findings is the detection of a massive intergalactic filament, a stretch of galaxies and matter aligned so precisely that it forms a structure over 1 billion light-years long. Scientists have seen filaments before as part of the so-called cosmic web, but this one is different. Its alignment, density, and repeating voids make it resemble a grid, almost like a framework laid across the universe. While mainstream cosmology argues that these patterns are the result of gravitational attraction over billions of years, the symmetry here is hard to ignore. The galaxies follow parallel paths. The dark matter clumps at exact intervals,